Hey everyone, welcome to the webinar. Thank you for joining. This webinar is about deploying Baserow in a scalable way on AWS. My name is Bram. I'm the founder of Baserow, and so for those who don't know me, I'm responsible for like the product development strategy within the organization. So I want to start with a short introduction, but before I do that, I want to start a quick poll about how you are currently using Baserow. So feel free to fill this one out. So yeah, about the webinar. The webinar is in collaboration with Blackbird. For those who don't know Blackbird, they're an agency specializing in managing cloud infrastructure on platforms like AWS, Google Cloud, and Azure. This ranges from setting up infra, maintenance, monitoring, etc. They're actually managing the cloud infrastructure for the production environment of Baserow.io. Yeah, and that really means that we internally at Baserow, we're much more focused at the development side of the product. And because they're managing all the cloud infra and the monitoring, it means that we can actually focus on building the product, and we don't have to worry about the DevOps side of things. So that's why we have this collaboration between Baserow and Blackbird for this webinar. So yeah, the webinar is focused at setting up a Baserow instance on AWS that's ready to scale. We'll take you through using the Terraform template that Blackbird created, deploying via Kubernetes, and yeah, explaining the concepts, understanding how to scale, and maintaining your instance. It is expected that you have some DevOps experience, some experience with AWS, and with Kubernetes is also nice to have. And of course, we expect you to know what Baserow is, but I think everyone already knows what Baserow is. If you have any questions, feel free to ask them in the chat. For the first part, I'm handing it over to Joeri, who is one of the founders of Blackbird. And so while Joeri is doing his introduction and his part of the webinar, I'll be monitoring the questions, and if I see some relevant things, then I'll interrupt Joeri and I'll ask him to answer that question. But yeah, Joeri, maybe you can start with a quick introduction about yourself, and then dive into it.
Yes. Good afternoon, everyone. My name is Joeri Malmberg. Like Bram already mentioned, I'm one of the co-founders at Blackbird Cloud. I'm a cloud engineer or cloud architect myself, with a background in software development. At Blackbird, we help product development companies in helping to have them host their apps in the cloud, help them optimize their SDLC, so to speak. We do that with small team. We currently have 4 people working at Blackbird, myself and a few of my colleagues, for which I have to give some special thanks to Melvin Stans, who actually did most of the development on the demo code that we will be sharing with you today. As Bram also mentioned before, we built our company on the following core values that we share with the partners that we work with. So we focus on bringing expertise, delivering reliable solutions, working in a transparent way. We believe big in partnerships like we have with Baserow, and of course the goal is always to accelerate the business and the development of the people that we work with, the companies that we work with. A short agenda for today. We'll be talking on, we'll go briefly over the Baserow and its components. Then we'll focus on how an AWS infrastructure could look like when designed for high availability and scale. We'll take a brief look at how to deploy it on Kubernetes using the Helm chart, and then we'll have a demo again from Bram in where you will use the environment and showcase some ops around it. Before I get started, we did have a poll. Let me show the results. Those get posted in chat, or everybody gets to see them. So it looks like most people are either self-hosting on AWS, Azure, or using the Baserow IO cloud. Then I think it's an interesting talk for most people. I hope you guys take away something from the webinar. Let's dive into the actual contents then, So Baserow. I assume everybody's already a little bit familiar with it. The first component to mention, of course, is the front-end server, which serves the web app that you're actually looking at and the end users use, of course. It's a React server. Then there's two APIs, WSGI API, which focuses on processing HTTP requests. This is the most heavily used API component. Then there's the ASGI API, which handles WebSocket connections, which are, for instance, used when you go work on a workspace together. Usually slightly less often used, but it really depends on the use case of your end users, I suppose. Then there are three components that are mostly active in the background. There is a salary beat worker active, which schedules tasks. Much like both the APIs, they also, if they have long-running asynchronous tasks, they put them on Redis, on a queue, and then either the salary export worker or the salary worker will pick them up. The salary export worker focuses mostly on slightly longer-running tasks. The salary worker focuses mostly on shorter-running tasks. Then obviously we have a database in use as well. There's Postgres, which backs Baserow up. All the APIs and the background workers connect to Postgres and do their use it as database. File storage is used by the WSGI API for uploading and storing and retrieving files, and the export worker publishes its exports there as well. And then there's the aforementioned Redis or Valkey. Both are supported, of course, which is used to manage the queues for the asynchronous jobs. All of these components can be found in the Baserow Docker all-in-one image that some of you might use to run your self-hosted version of Baserow. It's a convenient way to set it up because you don't need a whole lot of things. But it also comes with a few challenges when you're running a slightly more serious environment, and you're looking for some more high availability or scaling, right? Because when you're using the all-in-one image, you have one container with all your eggs in one basket, and when you want to have some redundancy or something like that set up, that is not possible in that way. It can be scaled vertically. Scaling it horizontally is it's much harder, right? Because it also contains the database and Redis, so that won't do you much good. So when we try to think of a way how to solve all these issues, and I'll be focusing this talk on AWS, but this could work with many cloud providers, of course. If we use the AWS managed services for Postgres, Valkey, and S3, we will be able to configure those in a highly available manner and in a way that they can scale very nicely for us, right? That already solves a part of our scalability challenges, right? So if we then focus a second on how the AWS infra will look like in the end, we start with something like this, where we focus on a design on high availability, on scalability and cost efficiency. Scalability is a function of cost efficiency, right? Because technically, if you were just to provision servers and resources to fit the peaks of your load, then you don't have a problem, but it will be very expensive. So if we can run on a slightly smaller setup and have it scale, we mostly gain cost efficiency. And yeah, the networking is also a big part of this, of course. So in the diagram here, you can see we've created a VPC, a network, divided across 2 availability zones. And in these availability zones, you can find redundancy for the Postgres, Redis, and the compute components. Well, it's either redundancy or there's a failover mechanism, I should say, because obviously our database, RDS database, will run with a writer and a reader endpoint. But if the availability zones where the writer instance is located, for instance, fails, then the secondary will fail over and become the primary, of course. Same with Redis or Valky. Kubernetes is, of course, also set up with nodes in different availability zones. And our public load balancer, the application load balancer, is, of course, able to divide the or load balance across availability zones. We have a few more dependencies that we use. S3 for file storage. Depending on the storage class that you pick, the objects in the bucket are automatically distributed across multiple availability zones. We will also use SES for sending emails in this example. So what we've done actually for this webinar is we made a code base to which there's a link available for everyone at the end. It's public code base where we have made a example deployment with Terraform. That Terraform will contain everything that I'm explaining here, and it will contain also the Baserow deployment and everything that we would roughly use to run this in a real production environment. Yeah, so when you design the deployment like this, then you have already covered the high availability and scalability for the base infra. One more look at infra before we look at the actual deployment and how to make that scale. We always have to, of course, also warrant for security and disaster recovery here. We often lead with, we're big fans of a big group of AWS services that help us achieve security, right? So starting with the WAF, with the web application firewall, we put that in front of the public endpoints that serve Baserow. The firewall allows us to, automatically block certain type of attacks like SQL injection, or we can block known bad actors, right? There's entire blacklists with IPs of bad actors that you can automatically block. Yeah, and a variety of other rules that help keep your endpoint safe. We like to use guard duty to help with intrusion detection in case somebody decides to, if something starts acting weird within your network or within your containers, we'll get notified. And second, we use Inspector, for instance, to scan for viruses on files, which is primarily interesting with Baserow, since end users get the ability to upload files to your servers, and then other users will start downloading those and do something with that, right? And we want to make sure to, of course, not be distributing any viruses. So we use Inspector to, for instance, scan our S3 objects and container vessels and our container images, for that matter. Yeah, I can go on about security for a long time, but I'll leave it at that one. What of course is also important to matter, of course, is right when you talk about security is IAM and identity and access management. You want to work with best practices and give everybody least required privileges. And that also applies to your network configurations in terms of, well, from Amazon perspective, when you're talking about security groups or network ACLs. Yeah, so that should cover the base for your cloud environment to be scalable, cost efficient, and highly available. Oh, I forgot the disaster recovery bit. Yeah, so say a real disaster strikes. We use AWS Backup to make backups from both from the persistent data that we use. So that would be the S3 file storage, object storage, and the Postgres database. You can configure it to make continuous backups or make hourly snapshots or nightly backups. And if somebody, for instance, for accidentally deletes a Baserow workspace or accidentally deletes some files and you want to roll back, then you have a backup and you can use the AWS backup service to either do a full restore or restore to a new database. And then, you can go into that database and do a partial copy over to restore those errors. And in case of proper disaster, then and your entire database is gone or no longer reachable, you can, of course, restore an entirely new database. And you can take that even to a next level where you also, using AWS Backup Service, you can copy your backups into either a different Amazon account or even into a different region. For even another added layer of security to not lose your data. So that's for the persistent data. In terms of disaster recovery, for the rest of the resources, we just rely on infracode, and everything else is a volatile resource that can be recreated. So there's no need to make more backups than that. So that covers the cloud bits. Like I mentioned, everything I mentioned here is you can review on GitHub on the repo that we will share at the end of the slides. I think it's listed on the references there. Then setting up Baserow on Kubernetes. Baserow has a Helm chart. The Helm chart you can install on Kubernetes, of course. There's an example of doing that on the aforementioned GitHub repository. It will allow us to scale Baserow's components individually, like in the code snippet that I linked here. As you can also see, I configured some bottom and upper limits for how far the pods can scale, because on Amazon things can scale infinitely, but so will your bill if you're not careful. Although they have good quotas and limits and whatnot, but still. I think this is where I give it back to you, Bram, and will you give people a demo on how to use everything that I just mentioned and how it sort of works?
Yeah, perfect. Sounds good. And thanks for giving us the high level overview of how a system like this is architected. And I think it's worth mentioning like the Terraform or like the GitHub repository that you mentioned, which contains a lot of like Terraform files. It contains all of this, right, Joeri? If I'm correct, all the backup part, the database part, it will set everything up properly for you on AWS without having to do it all manually.
Yes, there may be still a few values hard-coded here and there, so beware of those, but it should at least give everyone a proper inspiration on how to configure it properly and how to tie it together.
Cool. No, that makes sense. I'm going to stop the presentation then from here. I want to start one final poll that we have, which is like it's about what your biggest challenge self-hosting Baserow is. So let's start that one. And in the meantime, I'm going to share my screen. And what I think is really cool is, at least when we were working with Blackbird, they set up like our whole infrastructure, and kind of like how did we get that environment delivered. That's kind of where I want to take it from here. So imagine you have these Terraform files and you have like Kubernetes configuration values. From there, how do you actually work with your environment, right? And that's a little bit where I want to take it from here. So I want to do that live. I usually prefer to just live dive into it and show people how things work. This is the repository. So this is all publicly shared on GitHub, and that's something that you can access. So the part that I want to zoom into, so personally, I don't know much about Terraform, to be honest. I do know a thing or two about Kubernetes, so that's where I want to take it from there. So within this Terraform repository, we also have like the Kubernetes configuration files, and some of the things that Joeri was showing in his presentation, that's things that you will see back here, right? So the minimum number of replicas, maximum auto scaling, resource utilization, things like that. But I want to make it like really practical. So let's say you're using these Terraform files as a base. You have installed this, your Baserow instance is fully working as expected. One of the things you're probably going to run into within like 6 weeks after you deployed it is, hey, Baserow launched a new version. Now I need to update my instance to that version, and what kind of moving parts are all related to that. So that's what I want to show you. So where do we first start? If I open my browser here, one of the first things that I need to do is like authenticate with AWS, right? So you would need to have access to this environment. You would need to have administrator access. I have that luckily, and I'm already signed in. But using the start URL you have from AWS, you can get to this point. In order to actually connect with the environment or with the Kubernetes cluster in this case, you would need to use the VPN to make a connection. So what you would do from here is you go to VPC. From here, there should be like a part about the VPN. Client VPN endpoints, if I'm not mistaken. From here, you can download the client configuration. This is something that I have already done. So if you download the AWS VPN client, I've already added this one here. This is kind of like the configuration that you download here. You can very easily import it here by clicking on managing profiles. You can connect to that instance. Okay, cool. I don't have to log in. And then the VPN is going to connect. So let's give that a second to connect. Perfect, now it's connected. And so what you would do next is probably you want to log into SSO. You want to log into AWS using the same account. I've already configured all of that, so I just need to run the login command in order to gain access. And in order to access the Kubernetes cluster, I've prepared this command because I also don't know them all out of the top of my head. But what this basically does, it would, you have like Kubernetes client and everything installed on your machine. And if you run this command, it's like an AWS CLI command. It will add the Kubernetes context information to the configuration file of your Kubernetes client. So if I do that, I can then after that I can verify if I have selected the right context, which in this case it is, and because I'm connected to the VPN client, I should be able to access the Kubernetes cluster, right? It works. I can list all the namespaces here. And this basically comes from the whole environment that was set up using Terraform, right? So if you just set it up and you connect to the Kubernetes cluster that was created, you should be able to get the same thing here. What I want to do is like, this is the namespace where everything is happening in. So if I list all the pods that we have here, then you would actually start to see all the application components that Joeri was talking about. So it's the ASGI workers, the WSGI workers, the salary workers, and everything that's in here. I don't want to focus too much on the pods because Joeri has already explained that. But what I do want to do here is I want to do a quick check to see which Baserow version am I running here. So I should be able to do something like my Baserow describe pod to grab and show which image this is actually running. So this image is 1.35.0. We already have 1.35.1. So I want to do this update now. So it should be really straightforward. So if you go back to your Kubernetes values file, from here, I would just change the version number that I want to update to. And from there, I should be able to just run like a Terraform apply. So I would need to run some steps first. I would need to make sure that it's using the right AWS profile. I've checked out the repository. I've already run a Terraform in it, so I don't have to do that again. But what I want to do is run like Terraform plan to see, okay, what do we currently have deployed and what are the changes that it's going to make. So give this 1 second for it to complete. Okay, so it's only going to say, okay, we're going to change some Kubernetes configuration files here. This is looking good. I pre-checked that already. So I'm going to run Terraform apply, which is going to run the same check, which would have been more efficient if I just ran apply, but better to be safe than sorry. From here, it's going to run the same check, and then I'm going to confirm that it can actually make those changes. So I'm going to hit yes. Okay, so now it's going to apply the new the Kubernetes configuration onto the Baserow cluster. So what I'm going to do is get all the pods, give it a second, and now we see this migrate pod coming up, right? So this is all happening under the hood. You don't have to do this. You just change the version number. And then when the deployment process starts, it's actually going to start this migrate command. This migrate command, it runs database migrations, it clears some caches, it makes sure that formulas are going to, like literally Baserow formulas that are going to be updated. And once this is completed, then it's going to update all the applications that are running. So all the services are now going to be updated without any downtime. So if you update from one Baserow version and you don't skip any versions in between, so it's going from 1.34 to 1.35, you should be able to deploy that without any downtime because we're building like the database migrations with zero downtime. So we can first execute them and then update the application without resulting in any errors or without things actually breaking. So this is quite fast. What we can see is that the pods have already restarted. And if I would do like a describe on the image right now, now it says, okay, it's actually running this version. And if I would open the instance here in my browser, let me like refresh this page. It might take a second to load from here. And now I would go to the Baserow admin, to like the settings. It now shows that we're actually running that Baserow version. So that's pretty straightforward. What I also wanted to zoom in on is resource usage, right? Because each of these pods is using some resources, of course, and especially if you have like auto scaling and everything enabled, you want to be able to anticipate for those resources. And one of those topics that I really want to zoom in on is like the memory usage of these pods, because there is a bit of like a calculation that you can use and you can use in your configuration to see how much memory it would use as a maximum. So maybe the simplest thing to talk about is the WSGI workers. What we have, like the ASGI and WSGI pods, they are actually running Unicorn. And Unicorn is software to serve like HTTP requests and WebSocket connections and various other things. It's related to Python. It's what we use on the backend. But within Unicorn, you can ask how many workers it should start. So the number of workers is something that you can configure using an environment variable. So we should have this one somewhere here. Yeah. So it says here, Baserow amount of Unicorn workers is 3. What does that mean? It starts 3 workers per pod. Each worker will consume a maximum of around like 400 megabytes. So if this number is configured at 3, which is a pretty good sweet spot, it means that it's in this pod specifically, it will start like 3 workers, and it should not be able to consume more than 1200 megabytes of memory, because it starts to 3 of those workers. Same applies for the ASGI workers. If it's set to 3, it will also start like 3 workers here. And that means that if you want to set some resource limitations for your auto scaling, you would want to set it at like 1200 megabytes in that case. What does it mean, these workers? If you set this worker on the number 3, it also means that the WSGI pods, they can handle 3 concurrent API requests. So that's not per second. It means that if an API request takes a second to complete, then it means you can handle like 3 API requests per second. But if it takes like 100 milliseconds to complete, then you should be able to handle like 30 per second per pod. So that allows you to estimate a little bit, okay, how many of these API requests can I handle? How much memory is that going to use? And a very similar concept actually applies to the salary workers as well. So what Joeri said is they are actually picking up like async tasks in the background. So that could mean for the export worker, if you have a table and you are actually making an export, for example, you hit like the export button here. That actually starts like a background job that's being handed over to a salary worker who will do that work, so that all the HTTP requests can come through without being blocked. Same concept applies there. It says here Baserow amount of workers. So it's the same kind of thing, right? Per pod here for the export worker, also for the normal worker. It can handle, if this value is equal to 3, it means it can handle like 3 tasks concurrently, so at the same time. And then it also, the same memory limitations apply as well. If you have like 3 workers, it's 400 megabytes per worker, so this would also end up at 1200 megabytes. Now the thing is, if you would run like if you say, okay, show me the memory usage of all these pods, it's going to show less usage. And that's because of how Python works, right? So the more the system is being used and this system is not really being used, it loads more and more code into memory. So you would gradually see the memory usage going up, but it shouldn't exceed 400 megabytes per worker per pod. Cool. All right. I already saw a question in the chat if we're going to cover like monitoring, and that's really the part that I want to focus on now. Because if you can monitor your Baserow environment, it will help you to anticipate on certain scale. One of the things that I first wanted to show is Celery Flower. So what is Celery Flower? Celery Flower is something that we start as a pod here, but this is actually an open source tool that gives you insights in how many of these background tasks are actually running on the Celery workers, right? So if you look at this, you probably don't have any overview. Oh, is it running 5 tasks at the moment? Is it running 100? So if you want to debug a problem, you need to be able to see if these Celery workers are full. Now that we can do with Celery Flower. So what I need to do here is I need to forward a port just so that I can access the HTTP, like the web interface that Celery Flower has. So I will do that by copying this. Pretty sure it runs on port 555. And now I should be able to access this locally on port 555. Yeah. So what we can see here is there's currently 0 active tasks on the normal Celery worker and 0 active tasks on the export worker. How does it look like if I would import like a big file and it actually starts a long running task? So if I would import a CSV file, I've prepared one. So this one takes roughly 10 to 20 seconds to complete. So now this is starting a job. If I go back to Celery Flower, now you can see, okay, this one has turned into 1. This is a small bug in Celery Flower that you need to refresh the page. but I can actually see, okay, Baserow is running an async job right now with certain arguments. So you can see if there's like a job stuck or something like that, or at least you have insights in what is happening. So it's important that if you have like 3 workers per pod, for example, and you have 1 pod, it means you can run 3 tasks concurrently. So if there's like 3 tasks in here and you're trying to do another export, yeah, it's going to make you wait because there's no worker to actually pick up that task. So yeah, I think this is always super useful for debugging performance problems in Baserow using celery flour here. Something else that I want to show you is Sentry. So I'm not sure if anyone is familiar with Sentry. It's a pretty popular open source tool. But what you could do is both for the backend and for the front end, you could add an environment variable to your Kubernetes config here, put the Sentry DSN in here, deploy that, and then Sentry will automatically be activated in Baserow. So if for whatever reason you're self-hosting Baserow, you're performing an action, you're getting like a 500 error from the server back, that means something unexpected has happened. Good chance it will actually pop up into Sentry, right? So if I go to Sentry, this is the hosted version of Sentry. Yes, this is the right organization. If something will happen, you will see your arrows coming up here, right? So this is one that I triggered manually because it's like of our health check page to actually test and see if this integration with Sentry is working. It is. So if something happens, any error, you can debug it here. And if you report that error back to us because we need to solve a certain bug, it helps a lot if you make an export on this page. I think you can export them or a screenshot, or I think Sentry has some exporting capabilities. I don't know where it is out of the top of my head, but if you can share that with us in like the community or with your account manager or whomever you're in contact with at Baserow, that will help us to identify this problem probably quite fast. Another really important part is open telemetry collection. So for our production environment at Baserow, we are actually using Honeycomb. But you could also use Grafana plus Prometheus. It's kind of like the open telemetry protocol. You can configure to enable that in Baserow. You would need to set up some open telemetry collectors, but that's all included in the Terraform files here. So this one is configured to connect to Honeycomb because we're super familiar with Honeycomb, but it's compatible with any platform. What we've done here in this example is we've tweaked these settings a little bit so that it doesn't send over all the data to Honeycomb, because if you are processing hundreds of API requests per second, like what we're doing on baserow.io, that would result in a lot of data that's going that way. So we kind of have like a ratio of 5% in this case of full traces that are being sent. But if you use this configuration, and I don't want to go too deep into this configuration, but this basically means all the route spans, so all the HTTP requests are being sent to Honeycomb, and 5% of those, they will contain all the information of those requests. So that's like queries, celery tasks that were run because of it. And how does that look like? I should have it open right here. So this is how Honeycomb looks like, and this is basically just collecting events, right? So these are all like the raw events that are coming in that are matching this filter. I've added like is root here so that I'm only going to see all the API requests that are like being made. There's not that much in here, so because this is like a temporary instance that we have created. But if I would make this API request, and I'm going to refresh this one a couple of times so that you're going to see like a peak in Honeycomb, I should be able to see that peak of usage hopefully within the next minute or so. Sometimes it takes a little while longer, and that's because there's a collector in between, right? So it collects all the events before it actually sends it to Honeycomb. So if I refresh, I'm not seeing these ones coming in right now, but maybe it takes a little bit longer. I'm not sure what the configured period is of that. But you can actually see, okay, there's like 36 requests being made on a granularity of 15 seconds, 2.4 requests per second. For us, this is really interesting to, in our Baserow production environment, to identify, okay, how many API requests are being made, right? And which user is making those. So sometimes we see a big peak, and then there's one user. We once had it where an N8N automation was like stuck in a loop, and it was keep making API requests to our server. The user had no ID, but then we can identify that kind of traffic directly here in Honeycomb. Which user is that? What kind of API requests are they making? And what kind of things can we do to block that? Like, should we temporarily deactivate that user? Should we, I don't know, use the WAF, the web application firewall, to block something on the higher level because it still overloads our server? It's super powerful, and there's a lot of data coming in here to identify all those kind of situations. So even here, you could say, okay, group everything. It doesn't have that data yet, so I'm not sure. I think there's some configurations that is not correct, but normally you should be able to group by a user ID, for example, so that you can exactly see which user is making those requests. Yeah, if you're familiar with those kind of systems, you can just explore, okay, what kind of events are getting in here, which queries are slow. We could even group by an average of HTTP duration. So I'm not sure if this is the right one, but we should be able to, if you visualize that on like an average, you could see, okay, there's like peaks in response times that are happening. There's a lot of useful dashboards that you can make here, right? Do HTTP requests become slow? Is there a specific SQL query that is like super slow? Is there a certain user that's making a lot of requests? This, you can all track that in Honeycomb directly, or in Prometheus or Grafana. Okay, I don't want to zoom in too much into this topic. I just wanted to show you that is out here and that you can configure that. Something else that I don't want to demo right now because of time is PostHawk. PostHawk is kind of like an analytics platform where you can see, okay, how many, who opens which web page, for example. What kind of, yeah, it's more like product usage we send there. We have a very nice integration with PostHawk that sends all kind of like events. So from when a row is created, when a table is created. So this allows you to monitor like product usage on a much deeper level. It's out there. It's in Baserow. Just set these environment variables. Go to PostHawk, create an account, get an API key, fill out these two environment variables, do a Terraform apply, and yeah, it will become, it will start to work for you. So yeah, I think those are kind of like the most powerful things that we are using as Baserow ourselves to monitor things, right? And yeah, I think that's where I want to end things. I'm not sure. I'm going to stop sharing my screen now, and maybe Joeri, you also want to join the stage again. I just wanted to ask if there's like any questions about any of this. I see that there's been some questions in the chat here. I haven't read them yet, but I see Haidar, you're asking, for the current setup you've implemented, what's the average cost of hosting per month? Maybe Joeri, you can share some words about that.
Yeah, I think I already wrote something in return. I think the Terraform repo that we created comes with a plugin that can make an estimate of the cost, and that totaled to $704 for the month. I think, yeah, like I wrote, if we try a bit harder, we can bring down those costs a bit more through the various compute savings plans or reserving instances. Also, the current scaling is not the smallest one could set up, I must add, primarily for the compute. Yeah, I think maybe Bram, it's to put it in perspective, it might also be interesting if we can make an estimate on how many users do you think could run on this setup as is? Because that is always what it's about, right?
I it's always a very tricky question. We get a lot from our customers, right? Okay, if I have these server specs, how many users can I run there?
Yeah.
And I have seen customers on an instance doing both edges, right? Like using it with like 100 users, but maybe logging in once a day, making a couple of small changes. Yeah, you could put thousands of users that way on this kind of server, or with these kind of metrics, maybe even more. But you have other users who have like a lot of complex automations and do a lot of
Yeah.
high traffic, a lot of API requests, and then maybe like 5 or 10 users. So it highly depends how the schema of your database looks like, how much API usage you're doing, if you have automations, if you have applications, and everything that comes with it. So there's no easy answer for this one,
No,
Joeri.
exactly. No, that makes total sense, right? It's really highly dependent on the usage.
Cool. So I see another question here. How is Baserow performing without growing production with growing production database? Um, what do you mean specifically with that? If you if the number of yeah, so the number of tables, it doesn't matter that much. It's more about size of the database. Okay, so under the hood, what happens is if you would create like a table in Baserow, it would create a table in Postgres, right? And so it has kind of like the same disk usage as what you would expect, but Baserow can add a lot of things on top of that, right? So we have like a search index, which is being created in Postgres, which increases the disk usage. So yeah, it's very difficult to say, okay, yeah, if you have these number of fields and these number of rows, this is the disk usage that you will experience, because it depends on whether you enable those indexes, what kind of field types you have. So there is no easy way to calculate that, I think. But from a lot of like users, if you have like 70 gigabytes of storage for the Postgres database, you can do a lot, right? You can seriously do a lot, and storage is I think the cheapest part on AWS.
Yeah.
You're right, Joeri.
Well, you are definitely paying for it, but the compute weighs in heavier usually.
So I'm worried about having all user-generated content in the same operation/business table. Do you mean that within like the same database, or that you have because you have like a multi-tenant approach? Yeah, so you don't have to be worried about that. If you look at baserow.io, this is a multi-tenant instance. It is one single Baserow instance that we're kind of like horizontally scaling all the services for, right? So Baserow is built from scratch with security in mind, regarding your files, regarding your tables. So the isolation happens on workspace level. So in Baserow, you can create multiple workspaces. If someone is not, another user does not have access to workspace A, they will never be able to access that data. Baserow is also like a no-code tool, so it doesn't allow users to execute PostgreSQL queries or things like that. So you don't have to be worried that a user can access someone else's workspace. The software is made to handle that. Yes, and so this is a very good question, and this is one of the no. I really like these questions. No worries about going off topic. These are good things, right? Because this is related to running Baserow at scale. So we have thought about moving the tables that are generated, that we create dynamically in Postgres when you create a table in Baserow. In the beginning, we had the option of splitting that out across multiple Postgres databases, right? But the biggest problem we ran into, we really didn't talk about that in the beginning, is transaction safety. So what was happening at some point is if something goes wrong along the way, there were like two transactions running at that point, right? And they were kind of like not reverting each other. So you had like a state where all the user data was getting out of sync with the schema data, which was located in another database. So that's why we made the decision to just put everything in a single database. And the same applies for that works for if you would split things out on workspace level as well. If you have separate database for a workspace, for example, the transaction logic would not apply anymore, because if something fails, it doesn't roll back the proper transaction. So you get schemas that are going to be out of sync. Yeah, that's something we decided to solve on the application layer, basically. Yeah, so that's why we have that.
Yeah, and I think even at the largest of scales, right? If you look at the managed Baserow version, there's a lot of data in a single database, in a single schema, and it scales all right, I think. Yeah,
You
I
can do
think.
unlimited tables in Postgres. That we looked up, so that shouldn't be a problem. Yeah.
Yeah, I think the current Baserow IO production database has over 300,000 tables, I want to say, something like that.
I think even more nowadays. Yeah, it's a lot. There's a lot of tables in there, and it scales quite nicely. There's no performance problems on
Oh,
that front, because you can just increase the read-only nodes of your Postgres database. Yeah, that all works well. And yeah, so the really, from a security perspective, this is all separated on the API layer, right? So if people just have access to the API or the application, then you don't have to worry about this per se. It comes with more downsides if we're going to split logic into separate Postgres databases. But yeah, I think in the future we might want to do some sharding on certain levels, and then you would split it out over multiple databases. But that stuff definitely not needed yet at this point. Cool. Haidar, I hope that answers your questions a bit more. Okay, are there any other questions from people? Otherwise, I see, Mark, you said you have learned enough to know you'll be sticking with the SaaS version for a while yet. Yeah, don't be intimidated by this. I think this is kind of like, this is the setup where you can go to in the future, right? What Joeri also said, you can also just run the all-in-one image. It scales pretty well to a certain degree. If you have like 50 users or so, it's probably completely fine. It's also completely fine to stick with the SaaS version. All these security and scaling best practices we have implemented there. But yeah, you can also start with an all-in-one image or a container, or we also offer like managed environments, for example, if you want to have your private environment but don't want to have all the hassle of managing this by yourself. And you can always switch to a more scalable setup in the future. But yeah, I think if you don't have like 1,000 users, maybe you don't need all of this. You can have like parts of this, for example. Yes, the webinar will be available to watch afterwards. I suspect it will become available on our YouTube channel and your YouTube channel as well. And I think if you've subscribed to the webinar, then you'll get it as well. I see one more question from Gene. For those like me that use plain Docker Compose to deploy Baserow, is there a way to monitor the performance? I think, Joeri, are there some basic tips? So I can share some words about this, but I think you also have some input on this one.
yeah, I think technically you can do the same thing, where you connect an OpenTelemetry collector in that stack, and send your metrics to a place like Honeycomb or Prometheus, or any metric logging and trace store.
It's definitely possible. We're doing it in
Yeah.
our development environments, because the development environment of Baserow also runs in Docker Compose. So let me see if maybe I can show it to you really quickly. But if you just need to switch repositories here. So if I share my screen, maybe you can stop. Mind if I stop the presentation? Yeah.
Yeah. Oh, sorry. Go for it.
So if you want to do the OpenTelemetry collection, oh, this is the wrong one here. If you open the Baserow repository and you open the docker compose.dev.yaml, I think if you scroll all the way to the bottom, there is like a very simple version of the ODot collector. You can use this, right? Just put it in your docker compose config and add the API key, and you will immediately start collecting those metrics. Yeah. Yeah, cool. I think that's it. I think no more questions are coming in. So yeah, I want to thank you all for joining this webinar. I hope you learned something from it.
Yeah.
And yeah, don't hesitate to reach out either to Blackbird or to us in the community if you have some additional questions. We're happy to help you out.
Yep, for sure.
Cool. All right.
Thank you very
Bye
much,
bye.
guys. Have a nice evening. Bye.